Hello, everyone. Welcome to Roundtable number 4 for Spacemap Go. My name is Josh Furman. I work for technical support for Meyer Sound. With me, I have some esteemed panelists. Today, I have Mr. Steve Bush, Senior Technical Product Manager of Video. Then I also have Tice Roma, who is Technical Support Specialist. We also have some special guests today, and we'll introduce them in a bit. We also have been recording these roundtables, and they're all posted on the Thinking Sound YouTube page for Meyer Sound, and that YouTube page has a lot of information. We also have the help website, and the help website is your operating instructions for Spacemap Go. There's a lot of very useful information there. You might have a question, or you might have a feature request, or perhaps even a bug. And the best place to submit all of those is on meyersound.com/contact, and you fill out a form. So with feature requests, if you have multiple feature requests, fill out one form. But with a bug report, we always like to have an individual report for each one. We are actively looking at those, and our product managers and developers are really looking forward to hearing your feedback for Spacemap Go so we can decide what to do next with it. So if you do have features that you want, let us know. 3 weeks ago, we did a small living room 5.1 system. Then the week after that, we did a medium-sized theater. And today we're going to scale this to a very large-scale venue, something like an arena. And you'll see how easy it is to deploy even in these large environments with a lot of loudspeakers. So we're talking about large-scale deployment for the first section, but the rest of the time, we're going to actually have an artistic discussion and talk about how Spacemap Go has been used in the world right now. And it's a weird time, of course, because people are still working and still doing and not doing a lot of live shows, but we have had some use cases and we have had some people use it. So we'll talk to those artists very soon. And those guest panelists are Mr. Steve Ellison. Steve is the director of spatial sound for Meyer Sound. He is also the inventor of Spacemap. We also will have Mark Gray, composer and sound designer. Mark joined us on this one, but we're actually going to save most of Mark's time for the 5 p.m. show, and we'll talk to Mark. We have Denny. Denny is a front of house engineer as well as a system tech for large scale tours, and he mixes for Volbeat as well as Miguel. And welcome, gentlemen, and we're excited that you're here. We'll get to you in a second. Let's first talk about large-scale deployment so we can breeze through that and spend the rest of the time talking about the fun stuff. So here is our practical example, and it might be impractical in this day and age, but it might also be practical in the future. So this is an arena, and we have a very large-scale sound system that we've deployed in this arena. And what we're going to do today is talk about how to deal with something so big. Really, all of that comes down to system planning and working offline. And we've mentioned with Spacemap Go that Spacemap Go is a great tool that can be completely programmed offline before you step into a venue. And that is incredibly important when you have a large-scale venue such as an arena or a festival. Today, we're going to use those techniques and work through it as far as the system planning side of things goes. So here's our file. We received a map 3D file from a sound designer. And what we're going to do is figure out how we want to implement this and get the best use out of this system. And this system's huge. It's basically a frontal system of hangs of lion with 14 elements each. We have 24 LFCs for main subwoofers. There's also some 12-box hangs of leopard. And so in reality, that's 118 elements. And it gets even more crazy when we start adding surround fills as well. So the person that wants to do this has an incredible budget, let's say, and the production manager is really cool, and they're very audio friendly. So they're allowing us to put in a lot of surround sound speakers. And so we have actually 11 separate locations of 10 leopards each, as well as some subwoofer locations to fill out the low frequency energy to make full range sound and movement throughout the space. It was impeccably designed. It sounds beautiful. Here's the map 3D prediction. This is a 4K prediction, and I set the, if you know, have listened to any of our map 3D roundtables, we have sort of a pass-fail thing that we like to do with attenuation, to where we just set the attenuation to 12 dB, and then we adjust it to and look at it in 6 dB increments. And that allows you to sort of see general coverage pass fail your system. So the red is everything is in coverage within 60B at 4K. So it's a very good design, but we're not here to talk about Map3D. We're here to talk about Spacemap Go. So here is the Map3D file that I received from the sound designer, and it's my job as the tech to figure out how to get this infrastructure in and get it to work. And so the first thing I like to do is figure out what needs to move sound and what doesn't. So I'm going to clear this prediction, and we'll just look at the locations of our loudspeakers in this example. I can clearly see that we have 5 frontal system, and then we have surround sound. And so when I first get a map file like this from someone, and I'm trying to figure out my space map layout, what I generally do is figure out the locations of each loudspeaker. It would be highly impractical to deal with a space map that is 240 plus elements in the world. And so what we'll use is Milan AVB and send a space map mode galaxies audio to normal mode galaxies. And those normal mode galaxies are going to be actually doing all of the loudspeaker processing for each location. That way, our space map can be very simple and lay out quite nicely. And here we can see sort of how we want that layout to be. We will have frontal system of 5 nodes. Then we'll have some surround systems. So we'll have a wide right and a wide left, as you can see here. Then we'll also have some lateral surrounds, and then a rear left, a rear center, and a rear right, as well as some subwoofers to complete the full range audio. So in total, we've got about 21 locations. And we're not going to actually make a location for the outfills here. We'll actually just send whatever comes into this main speaker here, we'll send it into this outfill here and sort of treat this as one location. We're not going to even use derived nodes. We're going to do this sort of automatically to get that to work and just use normal mode galaxy. So the way I start doing that is I open up Excel, which I know it's crazy. And this is a template file we're actually working on that will allow people to build systems quickly. And when dealing with large scale systems, especially now when you have a galaxy that's in space map mode and a galaxy that's in normal mode, it's really great to start planning out your system. And so the first thing I do is I look at my map file and I try to start laying out how many nodes or locations of speakers I think I'll have. In this example, I know I'm going to have 5 up front. So here I just add them in left, center, right, and then I just keep going and start looking at my surrounds and count how many surround locations I have. And then I add them into my Excel file. And once I get past 16, I know that I'm going to need a second galaxy in space map mode because one galaxy is only broadcasting 16 channels of output. What I'll do is I typically just set up a space map galaxy and I just start labeling things. And I label everything the way I need it to. And if I need a second space map mode galaxy, I'll just copy paste and add a second one until I fill out all of the nodes that I need in my system. From there, I then figure out how many normal mode galaxies I need. We want to be able to control the line arrays easily, but we still want to use all of the loudspeaker processing that's needed for a large scale system. So to make the space map easy, we're going to use Milan AVB, and we're going to send the audio from these 2 space map galaxies into these normal mode galaxies. A galaxy broadcasts its Milan AVB signals simultaneously from its physical inputs and outputs. And there's 2 locations where a galaxy broadcasts its information. The first over AVB is what we call input splits. And that signal, when it's broadcast via Milan AVB, that signal is picked off post-input processing. So that's super useful for static feeds. So if I have a main left from my console into my galaxy, and I do not want to move that signal around, I can pick off the input split. That way we don't have to deal with any of the summing matrix. So Galaxy also broadcasts its output splits. And our output splits over Milan AVB are post matrix and post processing. And we said that Spacemap Go controls the summing matrix level of a galaxy. That is what it's doing. So if we don't want sound to move around, we should grab the galaxy's input splits. If we do want sound to move around, we should grab its outputs that are broadcast. And so that looks something sort of like this. We have a console. We plug in an 8-channel XLR snake into our first Spacemap mode galaxy. And those 8 channels of XLR get broadcast as input splits. And then also this galaxy sends its outputs as well. So if we have normal mode galaxies that aren't using Spacemap mode, we can decide that we want to pick off the input splits, and we can also pick off the output splits simultaneously. This allows for static and dynamic movement to happen. The way to set that up is very simple. First thing I do is I go into my Excel and I figure out what galaxies I need to send to from my satellite galaxy. So in this example, we're just going to do our first normal mode galaxy. We have more galaxies and the same process would repeat over and over. So the first thing I do is I know that my console static feed needs to arrive here so that I can always send to the left line array hang. So what I do is I decide in my Excel cheat sheet, I sort of decide what static feeds I need for the system. In this left galaxy, really I don't need the right, but I like to patch it anyway, just in case I want to blend it in. Here we go. I'm going to just use this left, and I'm going to send it to these 2 hangs of lion, and I'm going to also use it to send to my subwoofers. Then I'll also take the output of this first galaxy, which is output 1, and output 2, since these are 2 separate hangs, and via Milan AVB, I'll add them in to this next channel. And then we also have a subwoofer low frequency channel, so we'll add it there. And I know that's confusing and no one likes to look at an Excel, so let's just move on to Compass and show you how that gets set up. And so let's say my console is just broadcasting left, right, and sub. And what I'm going to do with this normal mode galaxy is I need to route it to its proper location. And if we look at Spacemap Go, what I did, as soon as I put my galaxies in the Spacemap mode and set up, the first thing I did was went to Settings, Locking Control. I locked out the channels that I don't want Spacemap to control. That way I can have a main left and a right and a sub feed and not have the summing matrix be involved with these channels. The next thing I'll do for these static feeds is I need to send them to my normal mode galaxies. And the way you do that is you just open a normal mode galaxy and you go into settings. We can see that galaxy 1, channel A, we can see that it needs to receive input split A from this galaxy. So this channel right here actually needs to go into this galaxy on channel A. The first thing I do is connect the CRF streams. So we want to clock our whole entire system to one galaxy, and we'll use the front of house main galaxy in Spacemap mode as our clock reference for the rest of our satellite galaxies. And so simply we'll just click the front of house galaxy as one, and we connect the CRF stream, which is the clock reference stream from Milan AVB. For more information on that, you can use the help website, but we also have a wonderful tutorial and roundtable on Milan AVB that we host on the Thinking Sound YouTube page. Once I've broadcast that CRF stream to this normal mode galaxy, I need to now lock this galaxy to that channel stream. And we'll see that once it's locked in, we get nice locks and locked. And so now this galaxy is clocked to the CRF that is coming from this galaxy right here. And then I can start routing audio. So I use my Excel cheat sheet and I can select an input split. And I know that channel A of this galaxy needs to receive channel A input split of this galaxy. And now, since we are broadcasting audio, we can see that channel A is arriving here. And notice on this galaxy that the outputs, nothing's assigned in the summing matrix, and the outputs are here. Even if I tried to use Spacemap Go to manipulate those, I can't because I locked myself out of it within the application. If I wanted to, I could use channel 4 here, and I could simply add a Spacemap. And I built a Spacemap for the arena the way I want it to work. And I could just move it around here. We'll notice that the matrix row of compass has changed because channel 4 of Spacemap is controlling input D of this matrix row. If I had audio on that, which let me start some audio on that channel. If I have audio there, we'll now notice that the audio is being routed over here on the outputs. And so this allows you to have static movements as well as dynamic control. And what we need to do is now assign those outputs to this normal mode galaxy. And to do that, you would just continue on with your cheat sheet. And we know that input split C is here. And then I would go in and take the left, and I just assign that to the left speaker, and I take the right, I assign that to the left center speaker, I'm sorry. And now we can see that the left channel split, I think I have something muted. And now we can see basically that the left channels are going to send here, and they're also going to send here, and we can individually route them. So that allows for a lot of flexibility.